In this video, I'll show you how to apply the Mann-Whitney-Wilcoxon Rank Sum test. There's a mouthful. So with this example, we have some ratings of students working at Showtime Cinemas, and 4 of the students come from college and 4 from high school. And these are the ratings given by managers, and these are the ranks of those ratings across both samples. So this student from college had the best rating, so he's ranked 1. The next best was this one, ranked 2, and so on. And the way to get those ranks is there's a function in Excel, rank.avg, and the .avg part means that any ties will be averaged when they're ranked. We have sample size of 4 in the first sample, and this is one way to calculate that sample size using COUNTIF. And similarly, sample 2, we have 5 students. We'll use mu and sigma more for the next example, so I'm going to skip over that for now. W looks at the sum of the ranks for the first sample, so 4 plus 1 plus 7 plus 2, and that comes to 14 in this example. And then to calculate a p-value is actually kind of difficult. So it's not really possible for us to do that by hand. And so what we'll do is let's see what Excel stat gives for that p-value. So this is a nonparametric test, and it's a comparison of 2 samples, and Wilcoxon, Mann-Whitney I mentioned there. So this is the one to select. And we'll select our data. So our first sample, sample 1, and then our sample 2. And we're going to do the Mann-Whitney test. Okay, we're not going to do the sign test, we're not going to do the Wilcoxon signed rank test. These are both different tests. We're going to do the Mann-Whitney test, which is the rank sum test. Under options, we're going to do a two-tailed hypothesis test. One way to think about this is as the distributions being identical under the null hypothesis and not being identical under the alternative hypothesis, or we can think of this as a test for the medians if we assume the shapes of the distributions are the same. And in that case, we can think of this as being a two-tailed alternative where the null hypothesis is that the medians are the same and the alternative is that the medians are different. Leave hypothesized difference as 0, significance level, let's leave that at 5%. And let's do an exact p-value calculation here. So this is the p-value calculation that we can't really do by hand. And so we're going to get Excel stat to do it for us. And we'll take a look at the results. So we're actually just going to focus on the p-value here. We're not going to worry about the rest of the table. And we can see that the two-tailed p-value is, if we look up here for a little more accuracy, 0.1905. And as the computed p-value is greater than the significance level, we cannot reject the null hypothesis. Okay, so these 2 distributions look like they could well be identical. And 0.1905, that's what I've just typed it in here because we can't calculate it using any distribution. And then alpha 0.05, and then our rejection rule, as usual, reject the null if the p-value is less than the significance level, which it is not in this case, so we do not reject the null hypothesis. Let's look at an example with larger sample sizes, because that actually allows us to use a normal approximation so we can calculate the p-value by hand. and I'll show you how that works. So we've got 12 customers from branch 1 of a bank, and these are their bank balances. And then we've got 10 customers from branch 2. And again, we've figured out the ranks using rank.avg. And you can see here there were a couple of ties. This customer and this customer both had $950 as their bank balance, and they've been assigned the average of their ranks. So this time we will talk about mu and sigma. So mu is given by this formula. So it's actually kind of figuring out a weighted mean of the sample sizes. It's actually not a weighted mean, is it? It's just a weighted sum of the sample sizes. Actually, it's not even that. It's just a calculation based on the sample sizes. Let's leave it at that. And then sigma, again, it's a more complicated formula based on the sample sizes. W, so this is the sum of the ranks in sample 1. Okay, so these ranks here are added up and comes to 169.5. So we can apply the Mann-Whitney-Wilcoxon Rank Sum test using Excel stat like we did in the previous example. And actually, let's just do that for illustration. So let's pick our samples. And then we'll let the test run. So we're in the bank balance sheet, working with these ranks for sample 1. And these ranks for sample 2. Do a Mann-Whitney test. Now let's get the exact p-value. And it comes to, let's make this a bit bigger, 0.037, or to go out one more decimal place, 0.0374. Okay, so that's what I've typed here, 0.0374. So less than alpha of 0.05, so we reject the null. So there does appear to be a difference in the distributions for these two branches in terms of customer bank balances. But I wanted to talk about a normal approximation that we can use here. So we can actually calculate this by hand if we're unable to use software to do the exact p-value. So for the hand calculation, we calculate a Z statistic. So it's the sum of the ranks for sample 1, 169.5, and we'll employ a continuity correction here because we're approximating a discrete distribution with a continuous one. And so we make a continuity correction, and because we're in the upper tail here, the value of W is bigger than mu, we'll subtract 0.5 to do the continuity correction, and then subtract the mean and divide by sigma. Subtract mu, divide by sigma. That gives us 2.044. And then the p-value using a normal distribution based on two tails. So it'll be the tail area to the right of 2.044 plus the tail area to the left of minus 2.044, which is the same as just multiplying the tail area to the right of 2.044 by 2. And that comes to 0.0409, and it's less than alpha, so we reject the null hypothesis. So you can see this approximation, it's close to the exact p-value. But the advantage here is we can calculate this by hand without having to have access to software that will calculate it exactly. So gives us the same result. We can actually do that in Excel stat as well. Get the approximate p-value, which is called an asymptotic p-value. So same setup for the samples. but under options, we'll select asymptotic p-value. And you can see here, you can apply a continuity correction or not, and so we will. And then here are the results. Okay, so there's the test statistic. Excel stat actually calculated 2.045. We got 2.044, close enough. And then there's the p-value. If you look up here, 0.0409 to 4 decimal places, which is what we get. And again, reject the null because the p-value is less than 0.05. So there's the Mann-Whitney-Wilcoxon Rank Sum test for comparing two samples.